we stop. If I have a circuit with one resistor and one supply voltage and a switch, if I put the switch on, the current will flow. If I put the switch off, I stop the current. So the point is that the value of the resistance is not constant. It depends on the amount of current which is flowing to it. So if I keep changing the DC supply, the current will keep changing. And the value of the resistance will keep changing. And the last value of the resistance will be dependent on the last value of the current. Something strange. It is not something usual. It is totally unusual. This memristor was suggested by Leon Schwab in California, Berkeley, in the 1970s. He expected زي كده الجدول الدوري بتاع مندليف لما اكتشفوا مواد كثيرة جدا لمجرد ان الجدول الدوري بيقول ان لازم يكون في الحتة دي هنا مادة تسد الفراغ. I'm sure you are aware about this. صح؟ بنفس الطريقة دي ليون شوا اكتشف ان لازم يكون في fourth element بالاضافة الى الاندكتور والكاباستور والريزستور اللي احنا عارفينهم لازم يكون في fourth element. واكتشف العملية دي ازاي؟ طبعا ده مش رسمي يعني لكن انا نقلته لكنه مفيد ان شاء الله. اكتشفوا كالاتي. قال ان احنا عندنا 4 electrical variables: current, الفولتج، التشارج، والفلكس. 4 electrical variables. وعندنا ايه؟ ريزستور وكاباستور واندكتور. والعلاقات بينهم كالاتي. العلاقة بين الريزستور هي علاقة بين الفولتج والكرنت اهي دي في باي دي اي بيساوي ار. والعلاقة بين الفولتج والتشارج هي بتاعت الكاباستور دي كيو باي دي في بيساوي سي. والعلاقة بين الكرنت والفلكس هي بتاعت الاندكتور ال بتساوي دي فاي باي دي اي. اذا لازم يكون في عنصر رابع، لازم يكون في فورس اليمنت بيربط بينه مين ومين؟ فلكس. بين التشارج والفلكس. وقال لازم العنصر الرابع ده تكون العلاقه بتاعته دي فاي باي دي كيو تساوي ام. ام طبعا مش بيوتو اندكتنس، ام هنا ممرستور. فليون شوا في السبعينات في كاليفورنيا قال لازم يكون في عنصر رابع. لكن it took about 40 years until people in Bell Labs managed to fabricate this fourth element, which is and it is now available. I think in 2008 it was developed for the first time. For the first time the memristor was developed. It is a new element, as I explained. It has a memory, and the relationship between the flux through it and the charge across it is this new term which we call M. There are of course nano devices. They can be fabricated on the nano scale, nanometers only, so they are a member of the families of nano devices. Where the memristors will take us, there is a big debate. If you go to the internet and the Google, you will find a big debate about the memristors. Are they going to change our life totally? Some people say yes, some others say no, and I will go in between. I will say they will definitely change our life, but not totally. They will definitely change our life because these are new devices, our new circuit element. Using it, we can have new devices, new technologies, and new changes in our life. So definitely they will change our life, but not totally as some very optimistic people say, and not also not going to do any effect like some pessimistic people say. Life is always somewhere in between. So definitely they will change our life. As I said, they are available. There are a few ground bit arrays now using this memristor, and they can be fabricated using metal and titanium dioxide, so they are not compatible with the silicon anymore. So the only invention which is compatible with silicon is a single electron transistor. The carbon nanotube and the memristors are not compatible. This is maybe useful for you. The circuit modeling of nano devices, all the device models which are available today cannot be used for circuit modeling of nano devices. It's all, again, in the industry, there are so many ideas in order to invent new softwares which are compatible with the new nano devices, taking into consideration their structure, and even which take into consideration the problems of the MOSFET, including the leakage current and so on. There is no need to go into the details, and of course taking the quantum effects into consideration. So in conclusion, nano electronic devices are here to stay. Carbon nanotubes are here to stay. Single electron transistors are here to stay. Memristors are here to stay. Which one of them will be influencing our life more? Allah only knows. محدش يعرف. بس ربنا يعرف. مين فيهم دول اللي هيأثر في حياتنا أكثر؟ محدش يعرف. دي عن في علم الغيب لسه. لكن بالتأكيد هذه العناصر ستؤثر في حياتنا. Because we are living and witnessing the third revolution in electronics أو in electronic devices. تمام؟ طيب جزاكم الله خير. I am done.
Are we witnessing this commercially?
Are we?
Commercially or?
No. None of these devices is available commercially. They are still in the research laboratories. But in the research laboratories, they are producing almost everything. Radio receivers, digital logic gates, filter gate arrays, anything you can imagine, but in the research laboratories. In order to be available commercially, it needs still more time to make them compatible with the commercial life.
Is it possible in the coming few years that we see the memristor as a discrete element?
I don't think so. This is a nano device, and it is not designed to be just a discrete element. It is designed to build billions and billions of transistors on the same chip. So I don't expect that it will be available as a discrete element. People are after it in order to integrate, in order to have billions and billions of transistors on the same chip, in order to make all the mobile sets now, or the mobile devices, available. Otherwise, they are not. So I don't think so, that they will be available in discrete form.
So does the invention or discovery of the
memristor
add a new field to electrical engineering in general? Because
of course,
capacitor,
I think that by time we have to change our circuits course. Because in our circuits course we teach students that there are only 3 elements. In fact, there are 4. And this 4th one is coming soon to affect our life. I think also that we have to change our electronic courses because we are focusing on MOSFET and bipolar junction transistors, and eventually, in 5 years or so, maybe 9 years, something like that, this will go. And there will be new devices available around us. So definitely this will affect not only our life outside the university, it will affect our life inside the university in terms of the curriculum we are teaching the students. We have to take this into consideration. As if the electronics will change and the circuits will change, then everything in the electrical engineering and the computer engineering, of course, will change.
You mentioned that we will today be combining the techniques of digital analysis and dynamic analysis to improve our circuits.
Of course. Not only today, this was long ago, but there was always a common understanding among some people that digital is a different word, totally different word from the analog. And we have to be either digital or analog. This is totally false and wrong. It was never like this before, and it will never be in the future. Except, of course, if we consider the period of time when there was no digital techniques at all. Yani 50 or 60 years ago, the television was totally analog. Today it is mixed. It is a mixture between analog and digital. So we can imagine a world which is totally analog. This is imaginable because we are analog. And everything around us, serving us, must be analog. We can imagine a world which is totally analog. We cannot imagine a world which is totally digital. But today, the common practice is a world which is mixed, analog and digital.
How can we classify these new ideas?
My ideas?
No, these new
These ideas, it works on both sides. As I said, there are